All right, this is the last example for our related rates problem. And I'm just going to walk you through this. Hopefully by the end you'll have 3 good examples that will assist you with doing some of the problems to try on your own. This says a trough is 10 feet long and 6 feet across the top. Its ends are isosceles triangles with an altitude of 4 feet. If water is being pumped into the trough at 9 feet cubed per second, or 9 cubic feet, how fast is the water level rising when the water is 2 feet deep? Okay, a couple things to keep in mind here. Altitude is the same as the height. So I'm going to just probably refer to that as h, just so you're aware of that. So we're going to start with our given. They already drew a picture for us, which is nice. So this is the trough, and we're dealing with water in the trough. So if you want to imagine like your water levels here, you've got water in this trough filling up here. So that's kind of what's happening. So we are given, in this case, it says water is being pumped into the trough at 9 feet cubed per second. So because we're feet cubed, this is the volume with respect to time. And we know that is equal to 9 cubic feet per second. And it's increasing, so we're going to keep it positive. It says, how fast is the water level rising? So we're looking for the water level, which I'm going to refer to as the height of the water level. So we're looking for dH dt. And that's when the H value is equal to 2 feet deep. It's based on that. So that's that. And when we do this problem, we got to think about the volume of this picture. This is considered a prism, and it's a triangular prism because the base here and here, these are both triangles. And so the volume is, if you remember from geometry, is equal to the area of the base, which in this case is the triangle, times the height of this figure. And so we can say V is equal to, if we're looking for area of a triangle, that's 1/2 base times height. And then times the height of this thing, which the height is staying constant. So I'm going to leave the height at 10 because we're going to keep that 10. This is the only one that's not changing. The 6 feet is going to change because as your water level goes down here, this length is going to get shorter and shorter. So that's got to stay. Changing. All right. So we don't have. Again, we've got some different variables here. We've got 3 different variables. We have a volume, a base, and a height. And so we have to come up with some way to make this into just 2 variables and things that I know something about. And so I know dVdt, which is my volume, and I'm looking for dH dt. So I have to somehow eliminate this B value. And if you recall from what we've done a couple times with our triangles, I'm dealing with this big triangle here and then this triangle here that would be changing arbitrarily depending on where it would be. I don't know where it's at. I'm just drawing it there. So I know that the base here is 6 and the height of this triangle is 4. They give me that information. I know that this is my B and this is my H, so then I'm going to use that to help me write a proportion. So I have 6 over 4 equals B over H. Cross multiply, I get 6H equals 4B. I'm trying to solve for B because I'm trying to replace that. So I need to know what B equals. So when I simplify this, I get B equals 3/2 H. And so this right here is going to get plugged in for B over here. So my volume equation now is 1/2 3/2 H, that's just this B value, times H times 10. And that's all just plugging these into this equation here, which I can simplify. I've got 1/2 times 3/2, which is 3/4. So volume is equal to 3/4. H times H is H squared times 10. And then I can bring this 10 out in front too. So I get V equals 30 over 4h squared, which is actually 15 over 2h squared when I simplify it. So this is my volume equation. And so I need to derive this 15 halves h squared volume equation and then start plugging some stuff in. So I'm going to do that. The derivative of V is just 1 dV dt. Derivative of this here is going to be 2 times 15 over 2, which is 30 over 2. If I want to think about it like that. Yeah, it's going to be 30 over 2. I'm just going to call this 15h. That'll work. And this is dH dt. All right. I think I can start plugging some stuff in here. Excuse me. I know dV dt is 9, so I'm going to replace that with 9 times 15. H is 2. And then I still have dH dt. So this is 9 equals 30 dH dt. And I can divide by 30 to get my dH dt. So I get dH dt equals 9 over 30, which I can simplify by dividing both by 3 if I want to. So this becomes 3 over 10, if you want to look at it that way. So finally, dH dt simplified is equal to 3/10. This was how fast is the water level rising? The water level is just the height, so this is just feet. And then my units were per second. So that is my solution for that last one. This picture seems a little more confusing than it actually is. This one probably was the more simple of all three of these examples. So you've got 3 good examples here, plus some of the examples that we worked through last week. Your homework then is to complete worksheet 2 on related rates. And we will go through some of those tomorrow when you get a chance to ask me some questions in class. Good luck.